Hello, in this video we'll learn geometry nodes by building a bevel node. How can we make a bevel node in geometry nodes? Well, here's my plan. We'll split the edges, scale each face, and then fill the gaps. Now let's get into geometry nodes. Create a new geometry node group. Let's split the edges using the split edge node. Let's now scale down each face using the scale element node. Now, how can we fill the gaps? We can use the convex hue node, but this will only work for regular shapes. If we make the shape irregular, this happens. So how can we solve this? Let's first try filling only the edges. Add a delete geometry node. Let's capture the index of the edges before they are split and compare the attribute with any number, and then connect the attribute to the delete geometry. We get two edges originating from one edge specified by this index. Now if we change the number we're comparing with, we get different pairs of edges. This means if we repeat this for each edge, we can fill all of them. So now add the repeat zone, put the delete geometry node inside it. Now we need a value to update in each iteration, so that the process can keep track of the iteration cycle. Let's now put the comparing node inside the repeat zone by connecting the count to the second value. If we change the iterations input, the edges disappear. That is because we're deleting all the geometry in the second round. So let's connect this to a geometry to instance node and output it on a new socket. This means we'll be converting each pair of edges into instances. Connect the first geometry to the first output geometry. This means that we will be using the same geometry as we go around the repeat zone. Connect the second geometry output to the convex hue node. Add a join geometry node and join the second geometry to it. If we increase the iteration, more and more edge gaps are being filled. We just need this to learn for all edges. So add a domain size node to know how many edges we had before we split them. Connect the edge count to the iteration socket. Now all edge gaps are filled. We are remaining with the gaps on points. Fill the gaps on the points, duplicate the repeat zone, change the geometry we are deleting to points, then capture a new attribute. This will be the index of each point before it is split. Connect the attribute to the compare node. Connect the points count to the iterations socket. Now we have filled the gaps formed on points. There is another problem which we need to fix, which is the face normals. The convex hue always creates, for example, two faces for vertices that form a plane. So let's just delete the one facing the wrong direction. First, add the sample index node, set it to vector, and set it to work on faces, and then sample the nearest face index. Connect the socket of the index to the sample index node. What are we sampling? We are sampling the normals. Calculate the dot product of the normals of the faces before they are split and the normals of the faces we are to delete. We have the red color on the outside. That means the object is inside out. So add a not Boolean math and the normals will be fixed. Now just sort things out and make the node group ready for use. There are a few problems with this node, like the performance problem. This node takes time to finish calculations on dense geometry. This is because we are using the repeat zone to turn each and every geometry. to an instance going in a straight line. This could have been faster if we were just using a node that had an ID input. This will be easier in Blender 4.1 as we will have the fill curve node which has a group ID input. Faster, then 10 times faster, and I've tried making it 100 times faster and ended up with the largest node group I've ever seen. I'll leave the link in the description for a simple Bevel node group which I think can be used in simple projects not having dense geometry, and I'll keep on updating every node if possible. Thanks for watching. See you in the next video.